Lesson 4, squares, cubes, and square roots. There's going to be a strong connection here to the multiplication that many of you have been working on these past couple of classes. But let's first start with some very important definitions. So there are multiple colors of highlighters in the bin. If you want to grab two colors, I'll probably be switching between two colors. Or if one makes you happy, stick with one. Our first definition for tonight is an exponent. An exponent tells you how many times a number is to be multiplied by itself. And that's the key piece, is that it's times itself. So for example, what it means by itself is 7 is being multiplied by 7. The number has not changed. 7 times 7, they're both 7s. Another way to write that expression is 7 squared. The 7 is the base, 2 is the exponent. So let's come up with our own example up here. Number 0 to 10. Let's try 1 to 10, not 0. Any number 1 to 10. 10. I need a second number 1 to 10. Let's make it fun, go 4. What is this called? Is that the base or the exponent? That's the base. 10 is the base. 4 is the exponent. Very good. And if you think base, right? So not base like in music base, but if something is at the base of an object, where is it?
The bottom.
It's at the bottom. So see how this is kind of at the bottom? Same connection to that meaning of base in math. The expression 7, how would you say this out loud? Before we read this part. Any ideas on that? Yep. Good. So that's one way. 7 to the second power. A little shorter way of saying it would be 7 squared. 7 squared. So when you hear that language, 7 to the second power, or 7 squared, 8 squared, 9 squared, 10 to the third power, we are immediately thinking exponents. Always, always. So let's do a little example off to the side. This one shows us or talks to us about why 7 squared is 49. Let's talk about, can I have another number 1 through 10? What would 8 squared be? How did you get 64? Very good. 8 squared means 8 twice. So 8 times 8, 64. We are always going to be dealing with multiplication. Always, 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 always. And again, we would read that as 8 squared or 8 to the second power. A number is cubed when the number is multiplied how many times? 3 times. Read. Number is cubed when it's multiplied 3 times. 3 times. So let's do an example. Number 1 through 5. What would this mean? How many 5s? 3 of them. 1. Go ahead and pick up today's packet. It's right there. 5 times 5 times 5.
So why would it be 3?
Because, good question. So the question is, why would there be 3 of them? This exponent right there tells us that.
Okay.
It tells us how many 5s are going to be multiplied together. Because it's always going to be multiplication. The question is, how many of them? So here, I know my base is 5, so I know that's what I'll be multiplying. This exponent tells me how many times. So that's why we wrote 3 5s multiplied together. The follow-up question is, what does that equal? Very good. Because we know 5 times 5 is 25 times 5. this would be an example of something you could put in the calculator. But let's use our mental math skills, right? So 5 times 5 is 25. How much money is 5 quarters? How many cents is that? 125? 5 quarters. $1.25. Very good. And then how many pennies would that be? 125. So whenever we're dealing with the number 25, it kind of connects well to money, quarters. Very good. So on your own, let's pick another number, 1 through 5. Any number? 3. Let's try 3 to the third on your own. How many 3s would that be? I would agree if the 2 was the exponent, but what's in that exponent spot?
3.
Yes, so how many 3s will that be?
3.
3 3s. So 3 times 3 times 3. What do we get? 27. 3 times 3 is 9, times 3 is 27. Very good. So think about what we've been doing with these numbers. We've been making them bigger, right, with multiplication. We can go backwards. So before we talk about square roots, what's the opposite of adding? Subtracting. What's the opposite of multiplying? Dividing. Well, squaring also has to have an opposite operation. And that opposite operation is called square roots. Square roots. To find the square of a number, we multiply. We just talked about that. To find the square root of a number, here's the key question. Think, what number squared equals this number? The symbol for square root is this awesome symbol right there. So I'll give you a moment to highlight that and read it to yourself twice. That's a key sentence right there. No problem. That packet is right there. Right? So what number squared, and by squared we mean times itself, equals this number? Kind of, but it has to match, right? So to give you an example, 20 does have factors, right? 10 times 2, but is 10 and 2 the same number? Okay. 5 times 4, that's 20, but is 5 and 4 the same number? No. In fact, there's no two numbers that multiply to get you 20 that's the same. So the square root of 20 exists, but it's going to be a decimal. For right now, we're going to be looking at ones that work out nice. Like, for example, 36. Can you think of two numbers, the same number squared that gets you 36? Perfect. So the example here is, what is the square root of 36? And we just thought, think of what number squared, what number times itself. So let's put a note, because that's key. When we say squared, we mean times or multiplied by itself, times itself. Think of what number times itself equals 36. Has to be the same number. Yes, very good. So in math, on paper, the way that we would write that, the square root symbol is kind of like a, watch the screen, it's like a little V, like that, but like a check mark. Make a check mark first, like that, check, and then draw straight across. So make a check, straight. So we would write the square root of 36 equals 6, and you're done. That's correct. Now we're going to take out our calculators. It's prompting us to bring the calculator into the mix. and work with those. So let's find those buttons, because as of now, they're available to us. Okay, you're welcome. Good. So if you look at your calculator, it makes a note to you that some calculators assign two functions to the same key, which is why if you look at your calculators, you see all the little green numbers? Yes. That's a second value associated with that key. Can anybody guess how we get to those green numbers? The green second button, correct. And it tells you that. To find the square root of a number, enter the number, so we got to press second. As soon as you hit the second button, you now have access to all the green numbers. Okay. You're welcome. So second, and then what are you going to hit? X, how would you read that? We don't say x2, we say x squared. Yeah, so it's kind of interesting, right? Because we said the opposite of squaring is square rooting. Notice how this calculator kind of put those on the same button? It's kind of a nice reminder. One is going forward, one's going backwards. So we hit second, square root, and the square root symbol should appear. Did it? Yes. So now type in 36 and hit enter. What do we get? 6.
36 with the regular box.
Good. So remember how we were talking about 20 before? How we couldn't really come up with a number times itself that would equal 20? Let's try taking the square root of 20. Just for fun. It's not in these notes, so let's just do it for fun. What do you get? Two square root 5, right? It doesn't come out nice. It doesn't come out to be a whole number. We could keep going and get a decimal. The point is it doesn't come out nice because no number squared or no number times itself gets you 20. Very good. So we are going to now use our calculator to find the square root of 3,136. So clear. So you do it yourself. Clear. And let's go square root. So second, and then the square root button. 3136. Can you repeat that on the screen? Yep. Hit the second button, and then you're going to hit the x squared, but it's no longer x squared because we're dealing with the green. Yes, I did.
So we're going to hit the second button.
Yep. So I'm going to clear it again. Watch. Clear. So hit second, and then see how this technically says x squared, but there's a green square root on top? So now if we hit that, see how it brings up the square root symbol for us? And now it's asking us to try finding the square root of 3,136. So now that I have this button, now we can just type in 3136, enter. What do we get? 56. Very good. What does that mean? I agree on 56, but what does that mean? So this is true. How could I get from 56 back to this giant number? Think of how we were moving forward up top. What operation were we using? Exponents are always associated with what? Multiplication. So 56 times what is going to get me 3136? Try it. Try 56 squared. So you also have a squared button. So instead of hitting 56 times 56, you can do 56, no second, don't hit second, just hit the x squared, and you should get a little 2 up high. You see that? So now it says 56 squared, right? Hit enter. What do you get? 3136. So the reason why that this 56 came out so nice as a whole number is because 56 squared equals that. And we're going to be digging more into that relationship, but I wanted to kind of get that in your heads before we move forward. It's time to practice. So go ahead and look at our first practice. I'm not sure how faint this first example is, but the model here gives you 6 to the third, and it says write it out using multiplication. So if I chose to expand this, what does expand mean? Make it bigger. That's all expand means here. How would I expand this out using multiplication? What would I write? 6 times 6 times 6, 3 of them. And then how could I figure out what this is? 6 times 6 is 36 times 6. So this would be 2 options. If this ended up being a non-calculator part, we all definitely now have the skills to off to the side do 36 times 6. If you do have a calculator, use it. So it's up to you how you approach it right now. See if we match on answers once you get that. Let me know if we match. Yeah. All the time. We good? Yes? Close? Maybe? If we have questions, I'm gonna pause here and I can come up with some more examples for us to work on. What are we thinking so far? Ladies, are we all good? Can we move on? Okay, this table right here is just reference. There's no work involved. This is purely a reference. It's called a table of squares because we're literally squaring numbers, right? So 1 times 1 is 1. 2 squared, or 2 times 2 is 4. 3 times 3 is 9, and so on. So step yourself through that table and say to yourself, for example, 6 squared, 6 times 6, 36. These are numbers we're going to become very familiar with.
Understand this?
Yes.
Well, how come this 36?
Good question. What's 6 times 6? What is 6 times 6? 36. So they said 6 times 6 is 36, but we still haven't multiplied this last 6, so they brought it down. Okay? And then they did 36 times 6 and got 216. So that's something you could use the calculator for.
Okay, now this is 5 times 5.
Yes. And what's 5 times 5?
So whatever I get,
you're done,
Okay.
right? Because here you only have 2 5s to deal with. Here we had 3 6s. So we did these 2 first and then the third one.
Okay, this one, 7 times 7 times 7.
Yes.
And 7 times 2.
No, 7 times 7.
7 times 7.
Yep.
Times 7.
Yes.
So I bring it down.
Yes.
Apply to this one.
Yeah, this is just a table that's given to you,
Okay.
because these are actually called perfect squares. They all come from a number times itself. So like 8 squared, 8 times 8, 64.
Okay.
10 squared, 10 times 10, 100.
Okay, so this is what you want us to do now.
Yes, so it's saying refer to the table to find these values.
Let me try.
Okay.
So, is it the same thing that happened here?
Yes. So this is, after, I'm going to show you where you can, I'm actually recording the notes right now. So on that website, I'm going to post tonight's class, and you can go on and catch up on the beginning of class right on your phone. Okay?
So is this textbook, how can I get, what if I need something like this?
Every time we have class, I have one of these for you.
It's from here?
Yes. So I actually have the 1, 2, and 3 that I can send home with you with an answer key. So at your pace, you can work on those first 3. All right? No worries at all. Okay, so we're going to refer to this table. How are we doing with the table so far? What do we get for number 5? Is? Good. This is just using the table. 8 squared is 64. How about number 6? 11 squared? 121. How would I read number 7 out loud? 18 squared. Very good. Is? 324. Yep. Nope, because 18 squared equals that number. No more square. It's saying that 18 times 18. So the question was, do we still need to put the square around this? The answer is no, because where 324 comes from is 18 squared equals 18 times 18, which equals 324. We can't add another square back in there ourselves. Good question. Number 8, who wants to read that one out loud? 16 times 16 is 256, yep. Now, once we get to 5, this is 5 to the third, correct? So how many 5s is that? 3. So this table is only going to get us so far. This table will get us how far? Squared. So that accounts for how many of the 5s? Only 2 of them. So we can still use this information. So 5 to the third, we can say is really 5 squared times 5, right? That's 2 5s times 1 more is 3. And we know 5 squared is 25. So now we just got to do 25 times 5. We said quarters is a great way to think of multiplying by 25. How much money is 5 quarters?
5 quarters is
$1.25. So 125 cents. 125. So with that idea in mind, how would you find 8 to the third? Think of how far will the table get you, and what do you need to do to finish? What are we thinking for 8 to the third? What's your approach? 8, yep, 8 times 8 times 8. So we could write that as 8 squared times 8. What is 8 squared? 64. Good. Times 1 more 8. What'd you get? 512? Did you guys get 512? Good job. So again, we started off with that mental idea, 8 times 8 times 8. But we know that we can write 8 times 8 as 8 squared. 8 squared is in our chart. 8 squared is 64. And then we have 1 more 8 to account for. So use the same idea to work on 4 to the third and 10 to the third. 4 to the third and 10 to the third. Who's got 4 to the third? $64. Did anybody else get 64? Yes? Good. Any questions on where 64 comes from? Who wants to see it? Anybody? Where did 64 come from? Let's see. So how would I read this out loud? 4 to the third. Do you agree with that? 4 to the third is how we would say this out loud? Not sure? So we start with the base. What's the base? What's the number at the bottom? 4. And what's my exponent? You can look at your paper. It might be easier than the smartboard. Number 11. Four to the third. So we're starting with 4 to the third. How many 4s is that? Yes. So we can rewrite this as 4 times 4 times 4. Good so far? Now, I want to utilize this chart to help me speed this up a little bit. How could I write 4 times 4 using an exponent? How many, if I just looked at 4 times 4, I could write that as 4 to what power? If I was only going to talk about 2 of them. To this, yes, squared to the second, same thing, good. So I could rewrite this, or I could think of it as 4 squared times 4. 4 squared, I know from my table is what? Is? You're right, 4 times 4, which is? Yes. And as you work with these numbers, they'll become more and more familiar. Okay? So 16 times 4. So now I can work with 16 times 4. What is 16 times 4? 64.
It's okay if they did it the other way, though.
No problem.
I mean, that, he's better with that.
It's all good. Many strategies, whatever strategy works for you. This is encouraging you to utilize the table, which is why we're breaking it up that way. But if it's better for you to straight up look at it as 4 times 4 times 4 and work it through, by all means do that. You really are. As soon as you do 4 times 4, you are doing 4 squared. You may not be thinking of it as 4 squared, or you may not be writing it as 4 squared, but that is what you're doing. Who's got 10 to the third?
Yeah, 10 to the, yeah, 10 to the third.
Yes, you both are right. Good job. 1,000.
Yeah.
Because 10 times 10 is 100, which makes sense. If you have 10 $10 bills, how much money do you have? 100. And if you have 10 $100 bills, how much money do you have? 1,000. Good. What's different about 13 through 16? What's that thingy called? Well, yes, the thingy, also known as square root. And again, how to draw this? Draw a check first. See the check? Check, and then a cross. We usually do put a little end on it. Okay. So yes, 13 through 16 have square roots, which means that the idea is now going backwards. Multiplication moves us forward. Square roots I'll be right back. Guys, classes are happening right now. Thank you. Okay. Square root of 121. I want to go backwards. So what number times itself gets me 121? That's the question. Can you find 121 in your charts? Where is 121 in your chart? Yeah, she found it. Look at 11 squared. Find it in your chart? So the square root of 121 is what? 11. Very good. I always put answers in a box. Have it. You don't have to. The answer is 11 because 11 times 11 gets me 121. You're answering the question, what number squared gets me that? Who's got square root of 16? What times itself equals 16? 4 squared is 16. So what's the square root of 16? 4. Just 4. Good job. Square root of 289. Yes. And square root of 196. Choose either 15 or 16 and check it with your calculator. Do the square root of 289 or do the square root of 196. Yes. So pick a number. Type any number you want. And now just hit that.
No, this one?
Yep.
Oh, I thought you had to use this one.
So hit enter. So that will get me multiplication. 6 squared, 6 times 6. Now if we want to go backwards, let's clear that out. Let's hit second. And now hit the square root button. See how you got the square root symbol? Now type 36.
I know that one.
Voila. Voila.
I was looking here.
Oh, gotcha. Yep, no, that's something else. Right now for tonight, we just need the green square root and that. Good? Okay, when you're ready, go ahead and move yourself into parts the 17 and 18. Purely calculator right now. Straight up calculator. Go for it. And at this point, if you have a good sense of where you're at and you would like to move forward, that is now open to you. So go ahead and move at your pace. There should. Good question. So let's say I wanted to pick something that you want to try. 4. 4 to the 4th. So we'll do it together. Ready? 4. See that little caret? That little upside down V? Yep, watch. So she asked a great question. She said, what if I want to do something that's not squared? So right now in the calculator, we're trying to work on 4 to the 4th. So the way that we would type that in, we would type in 4, and then look for this button on the calculator. Looks like a little upside down V. It's actually right above x squared. See it? Hit that button, and then what's our exponent here? 4. And then hit enter. What do you get? There you go. So this caret is the key to whatever power you want other than 2. Right? Great question. Yes. Go for it. Mhm. Anne-Marie. Anne-Marie. Sorry to surprise you. This one does have a square button right there.
Oh.
So we're going to reserve the caret for anything other than squared.
Okay.
Okay.
Okay. So we'll do it the way you
I didn't mean to scare you. Good?
Yeah, so
Okay.
if it's, to a third or opposite.
Third, fourth, fifth. Right, exactly. That's where her question came from. What if it's something other than square? Oh, good.
So this one is 21. So push that little.
No, we're gonna say that, you just tell me when it's a bigger back, 3, 4, 5. When it's square, when it is back, you're gonna do it. You're gonna get this in.
Oh,
Did you write the first one already?
yeah, not yet.
What do you want?
Calculator's going to earn their pay tonight.
Can you ask for a raise?
Yeah, that would be nice.
Whatever you say, sir. You push the button. Oh, you got it.
Question? You good? So once we're done with this calculator exercise, we're done with the pure skills part, and we're going to go into the real world part. It's not bad, I promise. Again, all of the real world we've been practicing with adding and subtracting, multiplying, dividing will really help us now. You'll see it come into play. Who's ready for real world? Who's ready to move on to area of a square? Raise your hand so I know. 1, 2, 3, 4, 5, 6. Okay. Miss Anne-Marie here. Miss Anne-Marie, are you good to make sure they're set for the calculator portion?
Sure.
Okay, great. I'm going to move on with them to the real world part. Okay. Area of a square. John works for Culver Carpets. On Tuesday, John's boss sent him to meet Sarah Vega. She wants to carpet her office. John measured her office. He found that each side is 24 feet long. John knows her office is a square. Definition of square. A square is a rectangle that has 4 sides of equal length. Square is a rectangle that has 4 sides of equal length. Now notice the connection. Back in lesson 3, you learned and you practiced that area is what times what? Area. Yesterday, how are you guys calculating area? Length times width. Very good. But it's making a connection for us here because is this room a square or is it not a square? It's a square, which means what about its sides? All equal, which is why it's making this connection that technically, yes, area is length times width, but because the sides are the same, length times width really becomes side times side, where those sides are the same. That's why you see a repeating S, because the length is the same. Now, just because we're working with letters, things don't change. So, for example, off to the side here, if I asked you to write, give me a number 1 to 10. 8. If I asked you to write 8 times 8 with an exponent, how would you write 8 times 8? What's the base? What's the number at the bottom? 8. And then what would the exponent be? How many 8s? 2. So 8 squared. Well, now I have 2 S's. So S times S, what's the base going to be? S, and you have 2 S's, so that becomes S squared, which is where this comes from. A equals S squared. So now we have this question right here. Here's our question. Which is the correct expression to find the area of Sarah Vega's office? And remember how yesterday I was always encouraging a picture? Notice how basic this picture is. Literally, it's just a square with our sides on it. But now we clearly have an idea of what this room looks like. So knowing that this is what her room looks like, I have a square with a sketch that has, to the best of our ability, equal lengths, labeled 24 on all sides. How would I find the area? A, B, C, or D? I would caution you that perimeter is also one of these answers, but we are looking for area, not perimeter. Which of these is perimeter? Which of these is perimeter? What does perimeter mean? What would you do with all of outside numbers? Add them. So which of those choices is that? B. So B is perimeter. We are not looking for a perimeter. So right away we know it's not B. What's the definition of area again? Not a trick question. What's our formula for area? That is true. That's the definition of a square. Length times width. In our case, these are the same. So length times width would be what? Which choice? C. But that's why we're talking about it, okay? So I'll let you just take a minute, take that in. Be careful, because clearly these answers are built in to, not meant to trick you, but there are other reasonable thoughts here, right? So we have to keep that in mind. Side times side, because here we're dealing with a square, or length times width. This is also where a picture could save you. Okay. Example number 2. Carpeting is sold by the square yard. John knows the number of square feet, so he found that by actually doing 24 times 24. So in your calculators, do 24 squared. Let's get that number. She got 576 square yards. Do you guys agree? Good job. Okay, so let's put that off to the side, because now we're assuming it's given here. He needs to change the square feet to square yards. Interesting. How many yards in a feet? How many yards in a feet? That makes no sense. How many feet in a yard? Let's try that again. How many feet in a yard? 3. Very good. So this is just reminding us of some real life math that we do know or have seen in the past. 1 yard equals 3 feet. So how can that help us? We have a diagram here, right? So this is a square yard. 1 square yard literally looks like this on the floor. That's how they measure. How do we translate that into square feet? You told me there are how many feet in a yard? 3, which is why they broke this up. See, 1, 2, 3 feet. 3 feet by 3 feet. So 3 by 3 would be how many square feet? 9. That's where this comes from. 3 times 3. Very good. So we have a fact that 1 square yard equals 9 square feet. I'm going to write that bigger and put it in a box. 1 square yard is equal to 9 square feet. And this really is applicable to life. I mean, if you go to Home Depot and something is in square yards, but you only know square feet of something you measured, you want to know how to figure that out. Now you know. So let's use this information that we've just talked about. Which is the correct expression to find the area of the office in square yards? Which is the correct expression to find the area of the office in square yards? Let me help you out just a smidge. 1 times 1? So put a giant 1 in this box. 3 times 3? A giant 9. I know, it serves purpose. So how am I going to get 576? I know 576 square yards. This is what I know. And I want square feet. True. So I understand why you're thinking that, because in general, we've been going forward with multiplication and back with using division. But let's reason on this. If I asked you how many square feet in 2 square yards, what would you tell me? 2 square yards is how many feet? 18 square feet. This is much bigger than 2. What is the connection between 2, this fact that there's 9 square feet in a square yard? What's the connection between 2, 9, and 18? Could I say 2 times 9 is 18? Because 2 square yards times this fact. This is just a fact. 9 square feet in a yard. 9 square feet. That's our fact. We don't come up with that number. That comes from a fact. Equals 18 square feet in the 2 square yards. So now I'm not asking you about 2 square yards. I'm asking you about 576 square yards. Principle is the same. So what do I do? What answer choice is that? Very good. What did I do wrong? Hold on. Let's see. Oh, way up here, we didn't find yards. That's why. What was this? We started with what? What measurement? Feet. So I made a mistake back up here. This was 576 square feet. That was my problem. I jumped to yards. We can fix it. This is math. This is learning. So 576 square feet is what we know. So yes. Let's see if division would be right. Yeah, so same concept. If you were going yards to feet, you would use what operation? We kind of did it wrong originally. What do we do first to get from yards to feet?
Divide,
Nope, we did not.
multiply.
Multiply, because there's going to be way more feet, right? But if we're starting with feet and going to yards, now we divide. So yes, the answer is C. It was just wrong direction. I mistook it as starting with yards going to feet, but that's the nice thing about math, is that it's very connected. So to go from yards to feet, you do what again? What operation? Multiply. And to go from feet to yards, you divide. So really it was worthwhile, because now you know how to do both. Let's write that down. That's a good idea. So at the bottom, yards to feet, square yards, not just general yards, square yards. Square yard to square feet, what do you multiply by? Multiply by what?
5.
What's that fact we were using? 9. Multiply by 9. But if I was going this way, if I was going square feet to square yards, so I was starting here and going back to yards, what would you do? Divide by 9. I guarantee you some of the practice questions are going to be dealing with square yards, square feet. So we definitely went on an unintended journey, but it was a good journey nonetheless. Good? Awesome. Practice. Yay. So as of now, I'm going to stop the video and I'll upload it to the website. For better or worse, like so for example, those students, I have them, which is why when they were being disrespectful in the hallway because security is kicking them out of the building, it's going to be on the video. There's nothing I can do about that. So that's why to the best of my ability, this only picks up maybe right here. I will repeat your questions so that someone listening will understand what you asked. So it's not that I didn't hear you, it's just I'm getting it so if you're not here, you can hear that conversation. Nice job.